Hello dear students, I hope you are fine and doing well in your studies. Students, today we are going to start from where we have finished in the previous session. Student, in this session, we will do some basic questions, examples, theorems, which are important regarding to this chapter. So, let us begin with the chapter itself. Students, in this class, we will study graph of different type of function, and we will also check the given graph is a graph of function or not by using vertical line test. If graph of the function is given, then by using the vertical line test, we can check that given graph is a graph of function or a relation. If we are given a graph of relation, then we can check whether the given relation is function or not. If it is possible to draw a vertical line which cuts the given curve at more than one points, then the given relation is not a function. And when this vertical lines means the line parallel to y-axis cuts the curve only at one point, then it is a function. Let example here. First graph is given, then vertical line cuts at 2 points. That's why it is not a function. For this, vertical line cuts 3 times, or you can say 4 times. It is not a function, means it is not a function, it is not a function. And this graph is a graph of a function, and this graph also is a graph of function, means figure number 3rd and 4th represent a function. What is the basic concept behind this system? As we know, if function is defined from set A to set B, then this is not a function. For single value of x, there is only one y, or you can say unique y. If we define a function from set A to set B and corresponding to one element, if there are 2 images, then it will not be function. Graph number 1 and graph number 2 are of this type. That's why they are not the function. So the vertical line test gives a proper judgment that given graph is a graph of relation or graph of a function. Now we are going to study some functions and their graphs. Here is the classification of function. Function can be categorized into algebraic and transcendental type. Algebraic function further classified polynomial, rational, irrational, and piecewise. Piecewise further into the modulus, GIF, fractional part, signum, or you can say LIF also. And transcendental type, it is a trigonometric, inverse trigonometric, exponential, and logarithmic functions. Now we will discuss the graph one by one. Firstly, polynomial. What is the polynomial? Polynomial is an algebraic expression of the form a0 x to power n plus a1 x to power n minus 1 plus a2 x to power n minus 2 plus dot 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 up to an, where a0, a1 are the constants and x is the variable, and n belongs to whole numbers. Okay. Then polynomial further categorized into constant polynomial, linear polynomial, and so on. For n equals to 0, it will be constant polynomial, means fx is equal to an. Now we are going to discuss the graph of constant polynomial. Here graph of constant polynomial is given. It is the y equals to c, or you can say fx equals to c graph. What is the meaning of constant polynomial? For different value of x, the value of fx is always constant, means f0 equals to c, f1 equals to c, means for any input the value of output is always c. And as we know, the value of input is domain and the value of output will be range. So for the constant function, domain is a real number, means you can put any number, and a range is the given constant value. For this example, range is c. This is the constant function, or you can say constant polynomial. Why it is function? Because it follows the vertical line test. A line parallel to y-axis cuts the graph only at a one point. Now, identity function. What is the identity function? A function which associates to itself is known as identity function and denoted by I of x equals to x, means I of x equals to x. If we put I1, the value is 1, I2, it will 2. Since x can take any values, so the domain of this function is real number. Corresponding values of ix is also real number, so the range is a real number. Means domain and range are equal of this function and it is a real number. What is the meaning of real number? Minus infinite to infinite. Students, identity function is a kind of a linear function. Some linear polynomial functions are there of the type y equals to mx. If m is equal to 1, then it is called identity function. This is the graph of identity function. If m is equals to minus 1, then this is a graph of linear polynomial. Here m is minus 1, the graph is here, and for m equals to 1, graph is here. As we know, the domain is on the x-axis and range is on the y-axis. In all these graphs, we can see that domain is the minus infinite to infinite is equal to a real number, and a range of the graph is also real number. These two graphs, here is a line for m greater than 1, means slope of a line is greater than 1, then this line will be the above the y equals to x line. If slope of the line lies between 0 to 1, such kind of lines will lie below the line y equals to x. For here, this is the representative line of y equals to minus x, and the lines whose slope is less than minus 1 lies above the lines, and whose slope is the between minus 1 to 0 lies below this line. All these are the graph of linear polynomial y equals to mx types. It is general linear polynomial, or we can say that it is a straight line. Let the equation of straight line y is equal to ax plus b. Now we have to find the point of intersection on x-axis and y-axis. For x-axis, we have to put y equals to 0. Here 0 equals to ax plus b. Simplify it. X is equal to minus b upon a, means point on x-axis will be minus b by a comma 0. For the point on y-axis, we have to put x equals to 0, and if we put x is equal to 0, then what will happen? Y is equal to 0 plus b, means y equals to b. The point will be 0 comma b. As we are observing here, if we put x from minus infinite to plus infinite, the value of y can be obtained from minus infinite to plus infinite. What is the meaning of this? Domain of the function is real number and range of this function is also a real number. This is the general linear polynomial function. In the category of quadratic polynomial function, we are observing y is equals to mx square type. If m is 1, then the graph of the function y equals to x square is here. If m is equal to minus 1, then graph will be x square equals to minus y. It is here. Value of y is always negative here and value of y is positive. That's why the domain of the graph is real number, as we are observing that we can put any value of x from minus infinite to plus infinite, but the value of y is only on the positive direction of y-axis, means range will be 0 to infinite. If we convert the m, or you can say m is greater than 1, then the graph will be like this system. If m is lies between 0 to 1, then graph is like this graph, and domain and range are same just like y equals to x square. Similarly, if m is lies between -1 to 0, then graph of this category. M is less than -1, then graph is of this category. And domain and range of this graph, domain is the real number and range will be -∞ to 0, means it lies in the negative direction of x-axis. This is the basic concept of quadratic polynomial function or graph of quadratic polynomial function. Now let us see cubic polynomial function. The cubic polynomial function can be categorized as a y equals to mx cube. For m is equal to 1, it will become y equals to x cube. The graph of y equals to x cube is here, and as we are observing that if we put x from -∞ to +∞, the value of y will obtain from -∞ to +∞, means domain is real number and range is also a real number. If m is equal to -1, in this category graph of y equals to -x cube, the value of y is positive if x is negative and the value of y is negative if x is positive. But if we concern about domain and range, the domain is the real number and range is also real number. This is the general cubic polynomial. If m is greater than 1, then graph of this category. If m is lies between 0 to 1, then graph of this category. And similarly, graph are here. But one thing is important, that for the cubic polynomial, domain is real number and range is also a real number. For the graph of cubic polynomial, domain is the real number and range is also real number. As we are observing that the graph on the x-axis lies between -∞ to infinite, and on the y-axis also from -∞ to +∞. Now it is the general quadratic polynomial of the type y equals to x to power 2n. For different value of n, graph will be y equals to x to power 4, y equals to x square, and so on. As we know, the graph is plotted here, and from -∞ to +∞, the value of y is always positive. The meaning of that, domain is real number and range of the graph is from 0 to infinite. It is the general cubic polynomial function. It is a graph of y equals to x to power 2n plus 1 type, means y equals to x cube, y equals to x to power 5, y equals to x to power 7, and so on. The graph are represented here, y equals to x cube, x to power 5 and x to power 7. And we can observe here that the value of x can be -∞ to +∞, and the value of y is also from -∞ to +∞. Main concept is this: the domain of this type of function is the real number and range of this type of function is also a real number. Up to now we have studied about the linear polynomial, quadratic polynomial, and cubic polynomial. Now in the category of algebraic functions, we are going to study rational algebraic function. The rational algebraic function is of the type y equals to m upon x, where m is integer. For example, y equals to 1 upon x, y equals to 2 upon x, y equals to 3 upon x. If we put m equals to -1, then the graph will be y equals to -1 upon x. The graph of -1 upon x is represented here, y equals to -1 upon x. For positive values of x, the value will be negative, and for negative values of x, the value will be positive. And we observe the graph that from -∞ to infinite, it is not defined at the 0, because at the point of 0 means when x equals to 0, the y does not exist. Means domain of the function is R0, or you can say all real number except 0, and range is also the R0. This is the graph of y equals to 3 upon x and y equals to 2 upon x, and comparison with the y equals to 1 upon x here. The domain of graph y equals to 1 upon x is also R0 and range is also R0. Here is one more graph, y equals to 1 upon x square type. Means in the category of rational algebraic function, if we observe this type of graph, then we can observe that for any value of x, means either x is negative or positive, the value of y is always positive. Means domain of the function is a real number and range of the function is positive numbers, or you can say from 0 to infinite. It never be 0, because for 0 the x should be infinite. This is not possible that we can put the value infinite here. The meaning of that, the value of y is never be 0, means range is from 0 to infinite. The graph of y equals to x square is here. In the category of rational algebraic function, the graph of the type y equals to x to power 2n plus 1 represented here, and y equals to 1 upon x to power 2n are represented here. We can observe easily that the domain of the graph is R0, means all real number except 0, and range of the function of this type is also R0. In this category, now here is the graph of y equals to x to power 1 by 3. As we know that the value of y for value of x equals to 8 will be 8 to power 1 by 3, means it is 2, and if x equals to minus 8, the value of y will be minus 2, means the graph of this function can take value from minus infinite to plus infinite, and we can put the values in this system is also from minus infinite to plus infinite. Means domain is real number and range is also real number. And here are the comparison of the graph y equals to x to power 1 upon 3 and y equals to x to power 1 upon 5. And in these graphs, we can observe that domain is a real number and range is also real number. Students, in the category of piecewise function, first function is the modulus function. It is also known as the absolute value function and denoted by fx equals to mod x. If fx equals to mod x, then we should know how to open the modulus function, or you can say how to open the mod x into the x. Mod x is an absolute value function. What is the meaning of absolute value function? If in this category, in this function, we put the minus 5, then outside the mod, the value comes out is 5. If we put 5, then value comes out 5. That's why it is called the absolute value function. Then how we can write minus 5 outside as a 5? We can write that it is the minus times of minus 5. Means if we categorize the mod x just like if x is greater than is equal to 0, then it is x, and if x is less than 0, then it is minus x. Now in this category, if we put x equals to minus 3, then we can observe that x is equal to minus 3 comes under this category, means x is less than 0. If we put here as x equals to minus 3, answer will be minus times of minus 3, it will be 3. If x is equal to 3, then we have to select the category x greater than is equal to 0, and your answer in this case will also be 3. That's why it is called the absolute value function. Domain of this function is set of all real numbers because fx exists for all x belongs to R, but mod x is greater than equals to 0, so the range is all non-zero negative real numbers. The graph of modulus function, or we can say that the graph of y equals to mod x is denoted here. This is the line of y equals to x for the positive value of x, and this is the line of y is equal to minus x for negative values of x. The domain of function is real number. We can put from minus infinite to plus infinite any real number here, and the range will be from 0 to infinite. From 0 to infinite can be written as r plus union 0. It is the r plus union 0. What is the meaning of r plus? As we know, r plus is from 0 to infinite, And if we take the union from 0, then you can say all the numbers from close 0 to infinite. This is the range of the modulus function. For x equals to 0, it is 0, and for other value of x, it is always positive. This is the basic fundamental nature of the modulus function. Now, properties of the modulus function. As we know, the nature of modulus function, now property A is here, mod of x whole power n is equal to x to power n whole mod. Second property is x to power whole mod can be written as xn, where n is even number. As we know, x square is positive, it is equal to mod of x square. Now property number third, mod of xy is equal to mod of x into mod of y. And property number D, x upon y whole mod is equal to mod x upon mod y. It is given that y is not equals to 0. To understand the property number E of the modulus function, this is also called triangular property. Here is the formation of a triangle whose sides are represented by the mod x, mod y, and resultant is represented by the mod of x plus y. As we know, in the triangle, the length of sum of two sides should be greater than third side, and difference of the two sides, length of two sides, is less than equals to the third side. Means the property number E can be represented as the triangle property of the modulus function, or you can say law of triangle for the mod function. Now here is one example of modulus inequality. As we know, if mod x minus 1 less than equals to 2, then x minus 1 will lie from minus 2 to 2 like this. Now solve it. X is greater than equals to minus 2 plus 1 less than equals to 1 plus 2. Solve it further. It is the minus 1 to 3. Means the solution of this inequality will be x belongs to minus 1 to 3 closed interval. And now we can understand this type of questions can be easily solved by using these formulas, or you can say these system of inequalities. If mod x less than equals to a, then always we should apply the system that x, it is less than, and same sign represented here, and it is from minus a to a. It is given here that a is the positive real number. Now this is the solution of this kind of inequality. If there is a one more question, mod x greater than equals to a, where a is again positive real number, here is also positive real number, then we can say x represent this sign here and here. Right hand side will be a and here will be minus a, and you can read this. If we are going to read, it is a x less than equals to a, means x belongs to minus infinite to minus a closed union a to infinite. Because if we read this side, then it is x greater than equals to a. Your answer will be x belongs to minus infinite to minus a union a to infinite. For example, if question is here mod x greater than is equal to 3, then our answer will be x belongs to minus infinite to minus 3 union 3 to infinite. And for this example, if x is less than is equal to 2, then your answer will be x belongs to minus 2 to 2. Now further, one more category. If x is greater than is equal to a and less than is equal to b, where a is less than b, then your answer will be x belongs to minus b to minus a union a to b. By applying this system, we can solve the inequality like this. If x is greater than and equal to 2 and less than or equal to 4, then your answer will be x belongs to minus 4 to minus 2 union 2 to 4. This is the basics of modulus inequalities. After the modulus function, here is the signum function. It is also known as signum x. What is the meaning of signum function? A signum function is defined as the follows, means fx is equal to signum x, The basic definition of 𝕉𝑀ax is written here, and this comes from the definition of 𝕉𝑀ax from mod x to x. As we know, if x is greater than 0, then mod x is equal to x, and if x is less than 0, then mod x is equal to minus x. By applying this system, by applying the value of mod x here, we can easily observe that for x greater than 0, the answer will be 1 because it is x upon x, and for x less than 0, answer will be minus 1 because it is minus x upon x, and for x equals to 0, your answer will be 0 because this is the definition of the 𝕉𝑀ax. According to the definition of 𝕉𝑀ax, the graph of 𝕉𝑀ax is represented here. According to the definition of the 𝕉𝑀ax, the graph of 𝕉𝑀ax is represented here. For positive values of x, the value of function is 1, and for negative values of x, the value of function is minus 1. Now you can observe that the domain of the signum function is the real number. We can put any number from minus infinite to plus infinite, but the range of the function is a set of only 3 values, minus 1, 0 and 1. This is the range of 𝕉𝑀ax. Here is one note for signum fx. If we are going to discuss about the signum x square plus 1, then definition of this will be x square plus 1 mod upon x square plus 1 if x square plus 1 is not equal to 0, and if fx is 0, then it is 0. This function is never be equals to 0. The graph of signum x square, you can say it is always a straight line y equals to 1, because for negative x it is positive, means it is greater than 0 category, and for positive x it is also positive, means the graph of signum x is y equals to 1, or you can say the value of signum x square plus 1 is 1. Students, now we are going to study greatest integer function or step function. The function y equals to fx is equal to greatest integer x is called the greatest integer function, where this is equal to the greatest integer less than or equal to x. For example, if x is lies between minus 1 to 0, the value of greatest integer is minus 1. If x is lies between 0 to 1, the value of greatest integer is 0. If x is lies between 1 to 2, the value of greatest integer is 1. And if x is lies between 2 to 3, the value of greatest integer is 2, and so on. Means you can observe that on the number line, in between two successive integers, let it is n and n plus 1. If x is lies between n and n plus 1, then the value of greatest integer will be n. This is the basic definition of greatest integer function. According to the values, graph of greatest integer function is here, means if x lies between 0 to 1, your answer is 0. If x lies between 1 to 2, your answer is 1. X lies between 2 to 3, your answer is 2. And for negative values from minus 1 to 0, your answer is minus 1. The value of greatest integer is minus 1. And the graph of greatest integer is represented here. According to the graph, the domain of the greatest integer function is the real number. You can put any values from minus infinite to plus infinite, but the range will be only integers, means range of greatest integer function is the integers. It is represented by I or sometime by Z.